Recording in progress.
So naputol tatang discussion na about the uh, determining the potential, determining the force from a potential energy. Okay. So for one dimension, for a motion along a straight line, a conservative force f of x is the negative derivative of its associated potential energy function. So in three dimensions, the components of the conservative force are negative partial derivatives of u. So if you have for example, in one dimension, makuha ni mo ang imong force, f of x, if you derive the derivative of the negative derivative of the potential energy function, negative the derivative of your potential function with respect to x for the but in three dimension now, okay, what you're gonna do is that makuha ni mo ang xy components of your force if is equal to the partial derivative of x u with respect to x I hat, partial derivative of u with respect to y j hat, partial derivative of z with respect to u with respect to z k hat. So partial means that you derive if you have a function x, y, and z, you treat the x for example partial of u over partial of x. If you're a function of x, y, and z, okay, uh, over it means partial of x means you treat the 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 y and z as fixed or constant. So if partial of y naman, kanina pod ang imong x og z mo'y fixed, constant. Ang kanina pod ang imong sa z na pod ang imo na x, y mo'y constant. So example na kani nga example sa to partial of z over k hat. Okay. You have a path with coordinates x and y slides on a level, frictionless air hockey table. So it is acted by a conservative force describing by a potential energy function. So you're given a potential energy functions. Okay, not that r is equal to the distance r is equal to x squared plus y squared on the table surface from the path to the origin. Okay, so find the vector expression of the force acting on the path and find the expression of the magnitude of the force. Okay, so for example, we have a force. Okay, to get the vector expression for the force, so we'll use this formula. Okay, okay. First is you will find the partial of u over partial of x. So this is uh, partial of so u is 1/2 k x squared plus y squared, okay, over partial of x. So meaning you'll treat now the y fix. Okay. So partial or the partial of so let's 1/2 k partial of x squared over partial of x plus partial of y over partial of x. Ito. So since y is equal to y is constant, so this the partial of the constant is equal to 0. And you have 1/2 k, the derivative of x squared is just 2. X, cancel this one. Cancel is equal to kx. Okay. Also for the partial of over u over partial of y. Okay. Yung x naman yung fix. So we have 1/2 k partial of x over partial of x squared over partial of y plus partial of y squared over partial of y. So ito naman yung maging ma-0 kay fixed naman na siya. So we have 1/2 k tapos 2y. So we have is equal to ky. Okay. So applying this formula, okay, applying the formula now. So your force now is equal to the negative of partial of u over partial of x just equal to kx. Kx I hat plus ky. This is actually ky. K plus ky j hat. Okay, so the negative. So your force out of this function, your force is equal to negative of kx I hat plus ky j hat. So this is your answer. So that's all for the what we call this one for chapter 7. Okay. This is the so we discussed the gravitational potential energy, the elastic potential energy. So when the total mechanical energy is conserved, we have some examples. We also have when the total mechanical energy is not conserved. We have the law of conservation of energy. What are the conservative forces? What are the non-conservative forces? And we discussed the law of conservation of energy. And we determine the force from it. So that's all for our chapter 7. To see you in the exam.